Let's speculate for a moment. What if life didn't need water or even air? What if it could survive under a sun so close it could melt lead? This is Specimen Unknown, where we blend real science with just enough imagination to ask, what else could be out there? Mercury is a planet of extremes. Closest to the Sun, it completes an orbit in just 88 Earth days, but its slow rotation means a single day, sunrise to sunrise, lasts 176 Earth days. Daytime temperatures soar to 800 degrees Fahrenheit. At night, with no atmosphere to retain heat, they plunge to negative 290 degrees Fahrenheit. Mercury has no true atmosphere, just an exosphere made of atoms knocked loose by solar wind and micrometeorites. There's no air to breathe, no weather, no protection from the sun's brutal radiation. Its surface is ancient, heavily cratered, and rich in elements like silicon, oxygen, sodium, and potassium. A place where nothing should survive. Nothing, except maybe this. Meet the Pyrosprite. It doesn't slither, swim, or fly. It hops in erratic bursts across rock hot enough to melt lead, chasing solar hotspots like a heat-seeking shadow. About the size of a grapefruit. It's not made of flesh nor bone. Its structure is entirely silica-based, formed from silicon dioxide, the same stuff that makes up sand, quartz, and glass on Earth. But where Earth's silica shatters, this creature's crystalline matrix is flexible at high temperatures. Its layered plates engineered by evolution to absorb, redirect, and store energy. Along its back, translucent ridges function like photonic sails, absorbing energy directly from solar radiation. That energy is stored not in cells, but in piezoelectric lattices, structures that convert light into small electric pulses, just enough to trigger its next leap. It has no lungs, no blood, no metabolism as we know it. When overloaded or endangered, it dives into the dust, using mechanical hinges, not muscle, and enters a dormant stasis, shielding itself with heat-dispersing fins until the surface cools or conditions stabilize. Its behavior resembles that of Earth's extremophiles. Short bursts of activity, long periods of rest, a flash of motion in Mercury's silence. Here's what makes this speculative creature scientifically interesting. On Earth, life is carbon-based. Carbon forms strong, flexible bonds, especially in water, but in dry, hot conditions, silicon becomes more chemically stable. Silicon dioxide is a rigid, heat-tolerant mineral that could, if conditions allowed, form the basis of structural biology. Similar to desert organisms on Earth, like tardigrades or seed shrimp, the Pyrosprite may spend 99% of its life in stasis, waiting for the precise temperature to trigger motion. It doesn't think, it reacts. Embedded crystalline logic gates could mimic a form of mechanical instinct, responding instantly to heat, light, and vibration. Let's rate the Pyrosprite using our speculative lifeform index. Intelligence. Similar to a jellyfish or a Venus flytrap, the Pyrosprite reacts automatically to stimuli without a centralized nervous system, yet their behavior can appear purposeful to an observer. Danger. The Pyrosprite isn't dangerous to life, but its bursts of heat and light could crack glass or fry delicate equipment. Like a living heat lamp, it's harmless, unless you're made of fragile tech. Plausibility. Like creatures living in deep-sea vents, the Pyrosprite's heat resistance and radiation absorption parallel extremophils adaptations, though its silicon biochemistry remains speculative. On a world Scorched by the sun and silenced by the void, the Pyrosprite flickers through the heat, a life form imagined from silicon and sunlight, following the same physics that guide Earth's most extreme survivors. You've just explored another world with Specimen Unknown. If you enjoyed this dive into speculative science, hit like, subscribe, and turn on notifications. There's more life out there than we can imagine. Until next time, keep wondering,